I'm going to take you through what we call the future of making things, and really this is, I guess, it's branding. No, don't get me wrong, it's branding and it's going to be advertising if you haven't seen it already from Autodesk. That's the sales and marketing part to it. But it's really, I guess, the way we're approaching the development and our approach to the industries that we serve, both in the AEC space, but as we see convergence in the manufacturing space and the media and entertainment space as well, and even down to consumer. So I thought I'd just give you a quick sort of 20-minute snapshot of our thinking on where we see the industry going and perhaps what's shaping our direction in developing solutions for you all to use in your industry. So start off with a couple of numbers. 50 billion connected devices currently. There's about 7.5 billion people in the world, last count. So more than 6 devices for every man, woman or child on the planet. Some of these are your smart iPhones, but the advent of Wi-Fi, cheaper network data, and certainly cloud capabilities means that we've now got devices that are connected from sensors to cars to all sorts of drones to anything else. And it's creating a bucket load of data out there, and it's probably still data, not quite information, at the moment, in all honesty. And I guess the question that we've got as players in the AEC space, what do we do with all those collection points, with all that data? How do we turn that into information? But 50 billion sources is a hell of a lot of information out there. So that's one thing driving sort of the way we look at things. The other is the huge population explosion that we're seeing globally. I think by 2100, that 7.5 billion is expected to hit 11 billion, was the last thing I read. We're seeing a lot of that, so population growth and population urbanisation as well. So people that are moving into urban environments. China's driving that a lot, of course. It's cooled off a little bit, if you read what the papers are saying as of late. But I was in Shanghai 2 weeks ago. There's still a whole lot of cranes going on up and down in that part of the world. But the estimation is we need to spend $4 trillion or close to $4 trillion a year to keep up with the building, the roads, the infrastructure, to cater for that population expansion and shift into urbanisation as well. So no matter which way you look at it, that's a whole lot of money to find every 12 months. And then the actual built environment itself. In 2011, there was 140 odd billion square metres of built environment. That's tipped to go to 182 by 2020. So 40 billion square metres of buildings out there that weren't there in 2011. More projects, driving that creation of those built environments is answering that population need or that transportation and infrastructure need as well. So it's all these pressures that are exerting, in different levels and different reasons on the environment that we work and we play in. And then if you have a look at construction itself, construction is 6% of global GDP, $10 trillion a year. Okay? It's not a small business at all. That we all play in. But according to Boston Group, the adoption of technology would actually potentially save up to $1.2 trillion a year in reduction in improvement in efficiencies and all those sorts of elements. So there's a huge impetus or reason for our industry, your industry, construction and building in general to have a look at improvements. One, to save money, sure, but also to be able to afford the projects that we do need as people that live in the world. So that sort of, wrapping all that up, that's, forced is probably a strong word, but it's made Autodesk look at what we call the future of making things. It's not the future of making buildings or cars or boats or bathroom fittings. It's the future of making all things, because we see that converging. The way you design a building today, we were just talking last night about it, is potentially very similar to how car design has been evolving over the past couple of decades around smart intelligence, around just-in-time materials handling, around fabrication. And we're seeing more and more fabrication on the building site these days, so building is becoming more of a manufacturing paradigm as well. So we look at it as the future of making all things, and it's something that's sort of tying all of Autodesk together in the different industries that we serve and that we create solutions for, to try and have a common sort of goal. And I mean, you see the future now. There's smart devices out there. There's smartphones and all the fancy sensors I spoke about. But we're looking forward to the day when maybe a drone turns up with your package from eBay and goes, there's your new Autodesk sneakers, thanks, and drops it on your desk. It's sort of rolling that tape forward. And even some of the stuff that that we've got today only a few years ago was, motion picture stuff, or something out of Star Wars, and I'll show you some examples of that relates to the space that we work in as well. But if you roll the tape back, about 30 years ago, we had these things called drawing boards, and ink pens and razor blades to correct errors. And Autodesk was a huge part, but others as well, in moving that to the CAD environment, the desktop computer-aided design environment, and we call that the era of documentation. A bit of a history lesson if you weren't around back then. We then moved to this thing called BIM, or 3D design, and we call that the era of optimization. So not just designing, but testing, simulating, improving. How do you know what something's going to be like before you actually make it? So that's BIM in the built environment. We see rapid prototyping in the manufacturing space. Nike make millions of shoes a year, but now they can test a shoe and every performance aspect of it before I actually make one. Cuts down on the millions of prototypes they actually make a year, as an example. So we see this optimization across lots of different areas. For us, it's BIM as we know it today and have done for the past 5 to 10 years. But it's really about optimizing what we design and what we create. And we talk about the ROI of BIM. We seem to have a heated discussion every year the night before BIM Mepos at dinner around the return on investment of BIM. And what does it mean? And this is the McGraw-Hill study that was done 2014 in the UK around BIM. And yep, it gives greater predictability, it improves scheduling, blah, 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 fewer errors, optimised design, etc. And if you were here last year, you might remember the gentleman from Princeton who came up and said, we don't bother about BIM ROI, we just spend that money and time on actually doing it because we know it delivers results. Why waste time and money measuring it when we can be on to the next project? An extreme view, but certainly some places or some points out there are in that space. Others are more sceptical. If you're a smaller firm, you need to justify those dollars for our software, other software, the investment in time and processes on that. So ROI still kind of matters. But I challenge that the only ROI that really matters is to the guy or girl that's paying for it, whether that's the owner or the operator of the asset that we're all building. Otherwise, we're all doing work on improving our part of the process. If you're an architect, maybe it's more rapid design or more efficient design. If you're an engineer, maybe it's risk reduction. If you're a contractor, maybe you're trying to reduce your errors on site. But people are doing a whole lot of work and not necessarily getting paid for it until the guy or girl that's paying for it sees value in that work. And so I guess our challenge as Autodesk, but as the AEC industry, is really moving BIM beyond COBie and IFC and all the elements that make it up from a technology point of view, and having a business discussion with the people that are paying for it, that are funding it, that are using it, that are measuring it, so that they're willing to actually see value in it. And don't get me wrong, there are owners and operators and facility management firms out there that absolutely see the value today. But there's probably none in this room, if I challenge that. There's certainly none at dinner last night, right? And that's something we, I think, as industry, really need to move this ROI of BIM more towards. Is what's the business benefits of that, or the social benefits of that? Because ultimately that's what drives the investment into all our spaces. So then you have a look at building and what technologies are builders experimenting with. Well, not a lot if you look at the top space, right? This was a 2015 construction technology report across all sizes of firms, from the super Genicons in Japan down to owner-operator small firms. But 70%, not so much. Right? This wasn't that long ago. This was last year. But we are seeing the proliferation of things like drones, of 3D scanners, of 3D printers. You saw some of the augmented reality and virtual reality technologies from Patrick earlier, from Microsoft, with the HoloLens and other technologies as well. In fact, we had one set up in our office last week, looking at some BIM models and what you can do in an augmented reality environment. But they threw me in it and put me onto a ledge. I don't know if that was by design or what, on a ledge in the mountains out the back of Seattle. And I was walking along, and they put me on these different viewpoints, and they made me walk up to the edge of the ledge like that. And then my tech guy was behind me and said, take a step off. No way. No way in the world. Until he shoved me and I actually felt like I was falling. But the reason I say that is these augmented realities are going from toys, to be honest, Pokemon, to be honest, no, I don't play it, to usable business tools. And as I said, some of the stuff that we saw a few years ago that was from Star Wars is now becoming reality. So take a look at this helmet, for example. So it's a smart helmet basically, a whole lot of sensors in it that I mentioned, but it's gone beyond just visualization. It's now data capture. It's now providing overlays in context of what that field operator is doing from a maintenance point of view, or certainly on a construction site as well. Science fiction probably not that long ago, borderline mainstream as we look at it today. So we come back to MEP just briefly and the challenges that we see. Productivity is still a challenge. A shrinking workforce, an ageing workforce in certain countries, a lost body of knowledge, I guess, from our workforce as they leave the MEP arena, and as well as just trying to find talent and skills within the space as well. So that's obviously driving a whole lot of challenges there. Down to finance, margins are slimmer, funds are harder to come by, public-private partnerships are challenging the way we actually fund these sorts of projects. Engagement is improving, and I think social media and rapid visualization is improving how we engage with stakeholders, but it doesn't happen often enough and early in the design phase. So if you're an aircon guy or girl or a contractor, it'd be really nice to have some of that engagement back in design phase, so that you're not sitting out there on site 12 stories above the air going, why the hell did they design it like that? It's never going to work. We see it in pockets, but we don't see it enough. We certainly don't see it right across the project life cycle. And then schedules. Anyone said, no, you've got an extra 6 months on that. Anyone heard that recently? No, it doesn't happen, right? It's more, how do we reduce it? We've seen projects that start construction while the design guys and girls are still trying to finish the design, right? And they're chasing each other in reality. It happens for real, just-in-time design and construction, which is probably not where you want to be, in all honesty. And there's been some advancements on that, right? So BIM mandates, for example, again, last night over dinner we had an interesting discussion around BIM mandates and the concept versus the reality. But the one thing that BIM mandates do is they bring the discussion of BIM to a higher level in an organisation. So in the UK we're talking about it, and it drives it. If you're the owner, well, you need to consider this because it's a government mandate over X million pounds. Then you must use BIM. What does that mean for me as an owner? If you're a CEO or a managing director of a services firm, then you're going to be having that discussion because you can't win work unless you actually comply and can deliver those sorts of services as well. So mandates, love them or hate them. I think the concept has been good. Delivery in certain cases has been challenged, but the concept has at least raised the discussion of BIM, as I said, from COBE and IFC and those sorts of things, which need to happen. Don't get me wrong. But it's changed the viewpoint on the value of it and how businesses approach it. And then there's been collaboration. We heard from Patrick as well, and it's a big focus for Autodesk. There's been work on collaboration. There's been work on technology proliferation, and there's been work on, as I mentioned earlier, the actual construction part of the industry becoming more like a manufacturer. We see manufacturing on site all the time, but they're all really fragmented approaches that we see. And if you look at fabrication, for example, you see a lot of these pod kind of designs. There was a skyscraper that went up again in China in, I think it was a matter of weeks, because it was modular Lego blocks. But unless you design like that or engineer like that, it's really hard being the guy or girl that's on the construction site going, well, if we did this modularly, maybe we could save X dollars or X time. It doesn't happen. So unless it's all connected together, then those sorts of efficiencies don't play, which drives me to, I guess, the area of connection, and that's where we see that next evolution in our industry. That how do we join all these dots? How do we join all these these sensors and this data and these teams and these dollars and challenges into some sort of cohesive working model for all of us? And that's where we introduce the concept of connected BIM. Now it's not a product. I'm not going to make any big announcements on anything like that at all. It's more a philosophy of how do we take BIM from design to actually making the thing, to using the thing, and then close that loop back again so that we learn in operation, we learn in usage, and we can design a whole lot better and make a whole lot better next time around. And so that's what we refer to as connected BIM. And it's really driving, I guess, from our future making things point of view, a whole lot of different elements in that life cycle. So we're looking at connected insights. How do we get insights into something before we start? How do we take the data that's out there, the infrastructure that's under the building, the traffic issues or flow that's around a particular plot, and use that in our design? Or on the other way, in the other direction, how do we take the construction of a new building and then measure the impact of the traffic flows around that? I don't know if you work out in North Ryde like me, but I've been out in North Ryde for about 15 years when it was a couple of plots on the Microsoft building back then where I used to work, and now there's thousands of people out there. don't know how many new roads there are out in North Ryde, Amanda, probably, yeah, none. Right? Because we don't do that in that disconnected fashion, right? We throw a massive building in that's got Optus in it, and 3,500 extra people turn up at work on Monday, and then it takes you 20 minutes longer to go home. Because you're not using those insights that are out there. We're getting smarter on that. Same with on the outcomes. So how do we look at various outcomes? That we're looking at different options, and I'll take you through some of those. Delivery, which I'll talk about today. How do we actually make these things and deliver these things in a more connected fashion? How do we connect our teams together? And then what do we do with the assets? So I'll just dance along the top of each of those. Connected insights, as I mentioned, really, I've almost spoken about it already. It's how do we take the data that's out there and connect it into our process? There's a whole lot of information, but you rarely start these days with a clean sheet of paper in your design. I don't think anyone has that luxury of a complete greenfields site. You've always got to factor in other elements: existing built environment, existing infrastructure, different challenges. So it's really how do we evaluate these in the real world context as opposed to what looks good on a mock-up board. Then we look at connected outcomes, right? There's infinite ranges of possibilities on a particular design, and we've got some smart software in something called Dynamo, for example, where you're trying to design X, whatever it may be, from a building point of view, and you can load a whole lot of constraints into Dynamo, and tell it to give you options based on the constraints that you put in. So rather than a designer having to go 15 different iterations of a design to see what that does, see what this does, see what that does, Dynamo will take the rules that you give it, and it'll actually design, through iterative design, different options for you. Optioneering, as it's starting to become called. Starting to be called. The good thing about it as well is then you can evaluate those options not just from a form point of view, but a function point of view. So look at the outcomes of those different designs. What does it do to the thermals? What does it do to the traffic? What does it do to the power consumption? Those sorts of things are getting smarter. But rather than having to do 15 distinct designs as a team, you can actually use the software as a bit of an advisor in that part as well. So they're the outcomes. Delivery is what we see in the construction field, in the contractor field. And again, Patrick mentioned this as well. How do we connect the delivery, or how do we bring BIM to the field? It was his words. For us, it's how do we do connected delivery. It's the same thing. That's right. How do we get all that knowledge and value and intelligence that was created from way back at conception, and avoid the situation where the contractor goes, well, I'm not trusting any of that data that the engineer gave me or the designer gave me. I'm remodelling again because I need to trust my own data. And it happens here. It happens all around the world in the largest of firms. It even happens within firms. There's a large Super Genicon in Tokyo that we work with that has an architectural division, an engineering division, and a construction division. And the construction guys and girls get the architect and the engineering information. They go, great, thanks for that, and they remodel. Right, because there's no trust or connection between the two. So we're trying to see how do we take all those smarts, bring them into the delivery process, but then actually push them out to the field as well. So Skanska, one of the large firms that we work with in the UK, has been doing a lot of work with BIM 360, so I thought we'd just have a listen to what they've got to say.
We've been working with Autodesk since 2011. We piloted BIM 360 Field on the Statoil project. In construction of this project, we used BIM 360 Field on iPads, saving time and improving commissioning and handover phase.
Today, we use BIM 360 Field for quality control before work starts and after construction has been completed. We have addressed many issues in advance of construction, which have helped us save significant time and budget by detecting issues before they escalate. BIM 360 Field has helped us capture the building site documentation during the entire construction process. iPads in the field has replaced the entire operation with digital cameras and Word documents.
We've been using BIM 360 Field for our safety and tidiness inspections. This has helped us to detect and fix potential safety issues. This has helped us to maintain our safety standards.
The use of BIM 360 Field has proven to be a success story for Skanska Norway. The tool helps us to work more closely with our partners in the construction process. Our workers on the ground love the ease of use, and they love always having the project data available to them on their iPads in the field. After 20 projects, we conducted a survey amongst the users of BIM 360 Field. 95% of the users said that they would recommend the use of BIM 360 Field to other colleagues in other projects. And that's what we call success.
BIM 360 Field is our standard tool of Skanska's construction projects. We have identified and closed more than 260,000 issues and taken more than 200,000 photos. It has helped us be more efficient, saving us time and money throughout the whole project lifecycle. BIM 360 Field is a fantastic software.
So an example, I guess, of some of the capabilities we've got today in the field environment, certainly something we're investing in and developing a whole lot further into the future as well. So, moving on from delivery really to connected teams, and this is the collaboration piece. Yes, we have solutions today in the marketplace, and there are other solutions as well, but looking at it more from a higher level, I guess, connected teams for Autodesk is really putting the data in the middle of all of that. And again, we're having a discussion last night around data gets shaped and changed across the project lifecycle. There's stuff that the architect does that the engineer doesn't need, or the engineer adds some bits and pieces, and it comes to the construction, the fabrication piece, and there's all these different data sets and lenses. And do you need the washer modelled at the start? No, but you might need it if you're the person that's actually designing that piece or engineering that piece of the componentry. What we're looking at Autodesk, and I guess part of the Trimble agreement as well, the thinking behind that is really that the data is at the centre, and as we evolve the product set and the focus on that, it shouldn't matter who or where you are in that design process. You shouldn't have to worry about the data that's there. It should be the lens that you view that data in should be altered depending on the purpose that you're coming in for. So you don't have to worry about whether it's a superset or it's too big because it's got all the architectural design in it as well, and you're just trying to do this small piece here. So where we're trying to go as Autodesk is really getting away from disparate data sets, both across our own portfolio and with partners such as Trimble and others in the industry as well. And Nirvana would be one BIM data set or one information data set. And then regardless of who you are or what you do, whether you're coming in from a manufacturing design point of view, it might be Inventor or Inventor 2020 by that stage. It might be Revit. It might be some other products as well, but you shouldn't have to choose or worry about what that is. You should just be coming in from a task-based in this whole, this whole sort of life cycle. Aspirational maybe, but that's sort of what's driving our product conversions and product development mentality back at Autodesk, because we sort of start to blend the different disciplines back together again as well. And then finally, connected assets. As I mentioned, there's sensors all over the place that are available these days. But if you're buying a 5-star or a 6-star building, how do you know whether it's 5 or 6-star, or is it running at 2? Is it just great marketing that's on the sales pitch? But it doesn't really operate like that. The advent of a connected asset is that you can then monitor in real time how the building's behaving, how the lighting's behaving, how the power consumption's behaving, how the AC is behaving, and modify on the fly to suit. And then that comes down to maintenance as well. If a light goes down, from a service level, it's great if you can actually be there and replace the light before the person who's working in that environment has to put a maintenance call in. So it's about actually analysing and testing and using the information that's created in real time from the assets once they're made, and then feeding that back into the next one that we make as well. Because no two buildings are the same. And we've had that conversation fairly regularly. It's not like a car where you get it once right and then you make a couple of million Chevys. You design a building once and you take the learnings out of that, and hopefully you do a better job on the next one. But that's a brand new baby in itself as well. So rather than starting from scratch, how do you take the performance and the function of an existing asset and then learn from that and move forward? So that's the future of making things at a very high level. They're just some key components of it that's driving our thinking at Autodesk. I guess as I mentioned, you look at the architects or the engineers today, and we blend that with motion picture quality visualization that's now being generated as you pitch to clients. If you look at the constructors, the contractors today, they're doing work that's of the manufacturing sort of lens or the manufacturing style environment of a few years ago. So these disciplines are all changing, and hopefully at Autodesk we can be with you along that way as we get to that future. So thanks for your time, I appreciate it.